All right. Good afternoon, everybody. I'm going to go down a little bit more of a technical route during this talk, but I'm going to try to walk through it pretty easy, and hopefully you guys can learn something pretty interesting. So the title probably only applies to me because I don't think anybody in this room want to hack mobile apps without getting out of bed except for me. But I'm going to walk you through that process of what it is and why I made this title. But so before I get started, I want to kind of walk you guys through that mobile applications. And so I'm going to walk you through sort of an automated system that I set up in order to essentially break into mobile apps, as well as what are some of the things I found while I was breaking into mobile apps. But when I say mobile apps, I want you to think a little bit differently. A lot of people, when I say mobile apps, they look at their phone, their Instagram, their Facebook, and they say, oh, you're hacking in order to get personal information out of those apps, right? So I'm targeting you, the consumer, and the information that's contained in the mobile. That is not what this is. Think about it as the mobile app is the new gateway to the enterprise, right? So when you look at web app hacking, people are hitting web apps in order to break into the web app to get into the enterprise. The mobile app is that new web app. Now I can look at the mobile app and break into the enterprise by the way that the mobile app and what it's doing into that company. It is the new gateway. So mobile by far is the new web. So keep that in context in mind. And then now let's learn about why in the world did I title this thing this way. Okay, so for those of you who may or may not be familiar with hacking mobile apps, I'm going to focus on iOS applications. So anything on iPhone. So when you hack mobile apps today, it's a real manual, pain in the ass process. The way that it's done is essentially you find an app that you want in the App Store, whatever happens to be, Bank of America, Instagram, Twitter, you name it. You have to download this app from the App Store, and it's encrypted by default. So you have to essentially decrypt this application from Apple. The only way to do that is you have to get a jailbroken device. You've got to run the app. You've got to allow Apple's hardware to decrypt it. And then now you have this unencrypted binary, which is your Twitter mobile app, for example. Now you take attacking methods like, okay, what do? I can analyze it statically by running it in NIDA Pro and looking through to try to find out what is this mobile app doing or how does it behave. Or the most common method is, hey, run it through a proxy, right? And then let's look at the web request that it's sending to the back end and see if it's doing anything interesting. Or you can even do things like called runtime analysis, which is inject libraries into the running of the mobile app so that you could reverse it live real time. So these are sort of the different methods that people take whenever they reverse a mobile application to try to figure out what's going on. Now, all of this is extremely manual and very painful and very slow. It takes a lab, you got to set one up, it takes a lot of time and focus. Someone comes to me and says, hey, there's a new crypto app that's out there that helps you, it's a crypto wallet. Can you take a look at it? Oh, I got to download it, I got to get on the lab, I got to manually plug it into my computer, I got to crack it, I got to run, I got to look through all this stuff. And that is just way too much work. I don't want to do that. So I am extremely lazy. And so for me, I think if you look at any technology that's out there today, it all stems from one great thing, which is it's all about laziness. How in the world can I do a lot of work without doing a lot of work? And so I was doing this pretty often on a pretty constant basis, and I was like, let's automate the crap out of this thing. Because ideally what I really want is I want a way to be able to real time at any time reverse engineer a mobile app, look at anything that's going on without getting out of bed. And so that's where sort of the vision of my product kind of came into play, which is what I want is this. Can I just lay in bed, pick an app on Apple's App Store, download it, crack it, reverse it, find flaws and issues in it, all without literally getting out of bed. That's really what this is really what my goal was, is to be able to do this. So how do I get there? How do I get it to the point where I can get this vision accomplished? And so I'm going to walk you through a little bit of that process. So first, the basics. Here's sort of how this works. I have an iPhone. I need a way from my iPhone on my app to be able to click it, go to Apple, find the app that I want, say Twitter, for example. I'm just going to use Twitter as an easy example. I'm going to say, okay, I'm going to get this identifier for Apple, a bundle ID, and I'm going to create a cloud service, a crack lab, as I call it. There's actually literally, we called it meth lab. I'm going to send the app, I'm going to say, okay, here is sort of the app that I want you to hack. And then how many of you guys are familiar with Metasploit? I'm sure many of you are, right? In Metasploit, when you pick something, you have a payload. You pick a payload. Here's what I want to do with this app. I did the exact same thing. There's a thing called dilibs, or dynamic libraries I want to inject into the app. I can pick whatever those happen to be. And then I want this whole crack thing to go over here and run all of this in an automated fashion of what I did manually. Essentially, download the app, it goes to Apple, downloads the app. It cracks the app, it runs it on jailbroken devices, which there's a pool of them, cracks the application, injects my bit of code that I want to run inside of the app so that I can look at it and reverse it the way that I want to. And then I want to re-sign it. So in Apple, when you distribute applications, you have to have a certificate, you have to have a signing. So in Apple, what's great is you can go get this thing called an Enterprise Distribution Signing Certificate, which essentially means I can make any app and then download it on all of your phones without jailbroking it. And that's one key, is I needed to run these things without jailbroking my own personal iPhone. I want it to run on anyone's iPhone. And then finally, I want it to be uploaded to a web page where I can just download it at any time, including yourself. So you could go to this web page and download my hacked app if you want to. So it goes off in the background, runs through all of this stuff, and then boom, downloads right onto my iPhone, and then I can start doing my reversing process. So this part is now, this is how I want it set up. It's all automated. Let's make this back-end infrastructure work. And then the next is, how do I actually see what's going on? Well, what's interesting is I found this cool little app called FlexLab, or FlexLib, that essentially is an app or a library that, as you can see here, is injected into the app that records all network requests that are going on inside of the app. So it's like a proxy, but without having a proxy, because all it does is hooks all the app's calls, and then you can see everything that's going on inside of the application. So for example, many apps today, they try to TLS pin so that you can't proxy between the mobile app and the back end. Doesn't matter anymore. I inject this thing inside of the app, I'm reversing it from the inside out. I can see all the network requests that are going on, I can see everything that's happening, all within the app itself. And by the way, you're going to see a little bit live demos of all this, or not really live, but you're going to see actual demos of how this works on real apps. The next thing is, I sort of modified this thing to include things called hacklog. And what I wanted to do is, when you're inside of an app, there are classes and objects. So any of you developers at all? Because I might be going, okay, a couple of you. I might be going a little low level here. But essentially what happens is, inside of an app you have classes and functions. Think of these as like forms on a website. And a lot of times, like, you ever been web hacking, you look for things like admin, or secret, or debugging, or testing. Same thing applies in mobile apps. Developers embed debugging, admin, testing, classes and objects inside their mobile app that do things you would have never imagined were possible, and increases your attack surface tremendously. And I'm going to give you examples of that. So this whole thing kind of all rolls into one. And this is sort of what my back end looked like. Pretty simple. I've got an API. This is what my custom mobile app looks to. I have a queuing system. I've got these pools of jailbroken devices. Like at my house, I have like 8 jailbroken devices, 8 iPads, that literally are just queuing. So anytime an app comes in, it cracks it, cracks it, cracks it. I can scale that out to infinite amounts of numbers. I can crack literally thousands of apps within minutes, right? All by having this sort of zombie pool system that's out there. This allows me to pick any app I want, boom, get it done. Gives me an API. I made a nice REST API, so you can run this through command line. You can run this through anything that you want, but I used it to build a mobile app. So putting it all together and lowering it all into one place, here's how it works. This is my custom mobile app. I pick my app, I pick my payload, it downloads the app, it goes through the phases of cracking, uploading it. It then puts it onto a nice little web page for me to download the app itself. So I click download, it goes and installs on my device. I now run it. I can then live real-time reverse engineer it all on my device, non-jailbroken iOS device, without ever getting out of bed. Let's see what it does. All right, so I've kind of walked you through this whole system that I built to essentially automate hacking iOS apps. Now the big question is, okay, that's cool. What now? What do you see next? What's next out of this? All right, so I'm going to walk you starting sort of simple. Let's start with Facebook. So here, this is my hacked mobile app. You can see the red border on there. And that's actually my little app that I use to run it. So you'll notice there's this overlay that you don't see in your normal Facebook. That's my dilib. That is the code that's now in runtime that has been injected. So now I go into my thing. I can see all the network requests that Facebook is going through. You can see the requests, the responses. It's essentially a built-in proxy inside the app itself. You can actually go in here and look at all the classes. This is all the heap. This is so anything that's instantiated or created inside this mobile app, you can kind of go through it. So one of the things I found in Facebook is they had a sort of debug thing. There's this thing called FB user preferences, which is a class inside of the Facebook app. When you click it and you scroll all the way down, let me go over here real quick. I'm going to pause it. These are functions inside of the class in the actual live running Facebook app. Do you see anything that looks interesting? Is employee, yes. Someone is bool, it's a boolean. Are you an employee? Yes or no? Yeah, absolutely. Anything else do you see in there? What's that? Is platform developer. Are we a platform developer? Absolutely we are. Yes, yes. So now, think about this. So now I'm running this Facebook. This is a live runtime Facebook app. I found some pretty interesting properties in this Facebook app. So, just like what you guys said, for sure I want to set that stuff. So let's go in here, and what's great is I can live runtime change these properties in memory. Switch it on. Yup. Switch it on. Absolutely want to do that. Go back. Let's go back to my Facebook app. And then, so now what's going to happen here is you're going to see internal settings menu just popped up. Oh, interesting. Look at all that. Look at this. So all development tools, back tools in Facebook, including things like, well, let me make sure I pause it so you guys can see it. Hold on. There's uploads. There's all sorts of things in here that you can look at. Look, you just keep going. You just keep going. How much more stuff can, oh, here we go. Like this. Things like upload power data. So all of these things go to Facebook backend APIs that are private. And so you never will see this in any proxy. You'll never see this because they're not active unless you're an employee. But when you do this, now I have access to these APIs, including many of them that were not authenticated properly. So now you can upload debug files directly into the server on where their backend happens to be because you have access to these things now. Hold on, let me continue playing here. So this is pretty interesting in the fact that, wow, who knew that in mobile apps, this is the kind of stuff that developers are starting to embed in. So like, for example, more minor stuff is I can get access to all the new features that are going on in Facebook. If they're beta testing different types of things that are happening, you can kind of see what's going on. All right, let's go to the next one. How do I go to the next one? Let's go to this one. All right, so this one, this is actually a conference app. So many conferences, you know, you have attendees, you want to look at the schedule, see what's going on. You see the exact same thing. I'm injected inside of the app itself. I can just go down to the disk where they save things on disk. And there's a database file located in the home folder of my conference mobile app. And when I click on it and you scroll through, you might notice, oh, it keeps everybody's information inside of my local instance of this conference app. All data and all registration information for the entire conference is stored locally, right inside of the mobile app. Let's go to one a little bit more fun. The New York Times. You guys know what the New York Times is, yes? All right, so this one is pretty interesting in that they have a class called beta settings, which is pretty interesting. I want to see what the beta settings controller is. So when you open this up and you go inside the New York Times, you can actually instantiate this thing, create the screen. I want to show you what this looks like. And boom, you get a beta settings screen that show things that are, developer-centric, etc. But what I'm going to show you is how to bypass their paywall, all using this sort of method. So you'll see things like expiration date, meters, all of these types of things. So let's see what it looks like. So when you open up the mobile app in New York Times, you're scrolling through things, you click on something, boom, start my free week. Hey, this is you got to pay for this content. This is stuff you need to pay for. I don't want to pay for this. How do I bypass that stuff? All right, let's go back into my little menu here. Go back into the right class that I'm using. And by the way, you have noticed, guys, you haven't left bed yet, right? You're still on the phone. Yeah, still on the phone, like doing this. It's awesome. I go in here and I say, okay, now I'm in their menu, their beta settings menu. What I want to do is just turn off the meter. Flip it off. Okay, now, no more subscription. Go back. Let's go back to our area where you can see it. Or I could change the expiration date if I wanted to too, but it's way easier just flipping the boolean. And then let's go back to our New York Times app as soon as I'm done doing all this. Oh yeah, there's a bunch of other crazy stuff here too. Like this is where you get new features and new updates that they haven't tested yet. Okay, so now as I scroll through, I click on it, no more prompt. So I can now go back in here, scroll through all the stories, all completely non-metered, bypassing the subscription. This kind of reminds me of old school cracking registration days, like where you reverse something and you crack it, but in the mobile sense. Okay, let's get into something a little bit more interesting. Let me pause it real quick. How many of you guys know what Gartner is? You know what Gartner? Okay, many of you. So Gartner is like sort of this really well-known analyst firm. So especially if you're a vendor, or even sometimes if you're an enterprise, you have to go kiss Gartner's butt in order for them to say your product is good. So they tell enterprise customers. Huge conference. Lots of executives, very, very massive presence in the US for sure. So Gartner, this is their Gartner mobile app. Same thing, it's a conference mobile app, so where you can kind of see what's going on. You can register, and you can see everyone's talking and who registered and who didn't. So I'm going to kind of walk you through a little bit more advanced usage of doing this. So in Gartner, they also had a debug controller. So this is sort of a debug screen that was in the Gartner mobile app. So you can do things like disable their TLS pinning. You can do all sorts of other interesting stuff. But that's not what's really interesting. What's really interesting is that they have a database that is on their, let me pause it real quick so I can give you some background. They have a database that's on their disk that's encrypted. So when you open up the mobile app and saved locally to your phone, there is a huge database that has encrypted contents. I want to know what those encrypted contents are, right? Because they downloaded it from their server, stored it in an encrypted form. What is it? So this is how we bypass that. So the first thing I start looking for is SQLite databases. So I said, where is it being saved? Do you see anything right there? Hold on, let me back it up. Back it up one bit. Okay, so this, let me make sure that you guys get it. It keeps playing all for me here. What do you guys see that's interesting? The encryption key, right there. I love it. So then that's the encryption key for the SQLite database file. This is pretty easy. So now that I know that it's there, this is how, again, runtime is great. Again, not leaving bed, although in this one I kind of had to leave bed a little bit because I did have to get my laptop in order to decrypt the actual database file. I go pick the Gartner attendee SQLite database file. I open it up. Boom, it's encrypted, you need a key. Oh, fantastic. I just pulled that key right out of their mobile app. So let's copy it, let's paste it. I'm in. Oh, so there you go. Now all of the attendees and all of their contact information all stored locally inside of the mobile app of the Gartner conference. Also including all of, by the way, their Google Plus secrets, their Twitter secrets, their Facebook secrets, tokens, etc., all embedded inside of the mobile app itself. So, pretty interesting stuff, right? Like, so you can sort of see how runtime hacking these mobile apps, it's amazing the types of things that you can actually get access to. Now, I don't have videos of the rest of this because I'm going to flip through it pretty quickly, but I'm going to show you some of the other things that you start seeing inside of mobile apps. For example, Uber. Uber has an employee settings screen, as you can see right here. Very cool stuff. This was sort of an older version of it, but what was an amazing feature in Uber is in their employee UB developer screen, they had enable all car types and disable surge property. So then when surge was going on in Uber, flip it, no more surge. It's great. Doesn't exist anymore, but was fun while it was there. Bank of America. Bank of America had an admin console. So you actually here had, it's called admin console inside of the application. You had the current environments, the developments, and all the staging and backend prod, QA, etc. endpoints and the APIs for Bank of America that these things were looking, including ones that were, again, have the ability to upload log files, debug files, all to Bank of America APIs, all randomly. It's all no authentication. You can do that. Good stuff. Who knew this stuff was in mobile apps, right? Like, it's like the web, like 10 years ago. All people do are just like, oh, making the same mistakes, but they're doing it, and in fact, I think they're making worse mistakes because they feel like the mobile app is trusted, right? They don't think about it like, I'm using your mobile app as an attacker to get to you. They're just thinking, oh, it's on an iPhone. It's secure, so we don't have to worry about it. So going through, there's a lot of fun things that you can start going through with these mobile applications, including like what I showed you, developer debug screens, hidden APIs, you name it, from every company, from Gartner to State Farm to all of these types of things. Dropbox, they've all got these debug things that have access to APIs that extend out the attack surface. Static crypto keys and credit card numbers, all stored locally. You get tons of master crypto keys all in these. This is for a famous cryptocurrency mobile application. All of these things all stored in there, all going to different types of areas in their back end. Private APIs. This is great, actually. This one was cool. I found quite a few of these where you could actually have the right token that went to their internal app distribution model. So a lot of have services that they distribute their iOS apps internally to employees. You could actually go there directly if you do the right URL and token. Boom, download their app before it was even released to production. Great stuff if I'm Uber versus Lyft, right? Bypass in-app purchases and cheat in games. I already showed you some examples of that with the New York Times. There was one that was a great poker game one, which was kind of cool. So in the poker game, so you would play the mobile app, and you would play a hand. Now normally at the end of the hand, you would only show, and depending on who, the winner would show their cards, and maybe the loser would show their cards if they so chose. But in memory, at the end of the poker game, you saw everybody's cards. So you could actually see and monitor everyone's hand during the game, only in memory, not in the UI. So again, other interesting ways of being able to cheat at some of this stuff. And that's the end of my presentation. Hopefully you guys learned something new, something interesting. What's my time? Do I have any other time for questions?
Yeah, you have time for questions.
All right.
You have 10 more minutes? Yeah.
I have 10 more minutes. All right. I went a little fast, but hopefully it was understandable. Any questions? Yes? They have been, yes. Otherwise, I wouldn't show them to you. All of them fixed. This is the issues that you saw were easily over a year old.
Yeah, just a question like.
Yes.
Yeah, just a question like, because since I was 9 or 10, like the Apple kind of only distribute apps partially to the devices. Does that affect how we download the apps to?
Bitcode, you mean?
You mean like? they may just distribute a version that only contain the binary for your specific devices.
Yep.
Is that going to affect your systems anyway?
No, it doesn't.
That's good.
And by the way, this system was built truly out of laziness. This is not something that I'm offering as a service or giving it to anybody. Like, I don't care. Like, it was done because I had some spare time, well, sort of some spare time in order to put the thing together. Oh, there's many. Okay.
Do you plan to move the entire thing to the virtualization platform like just announced a couple of months back in something?
No, I'm not planning on doing anything with this except randomly using it when I need to. And actually, it doesn't even work anymore because I developed it on Swift 3, the client app, and I have to upgrade it to Swift 4, and I'm too lazy to do that because I got other things. So the actual client, I have to like convert it in order to make it work again. But you know, I felt, so I actually did a lot of this at my last company called Blue Box. We focused on mobile security stuff. And so that's where I did it. And then now that's been sold and kind of moving on. And now, like, I don't really touch it that often. But I figure it's interesting stuff that you learn.
How long did you spend to build the whole lab, including the tools, the box and stuff?
I don't know, but I would say probably, you know, again, part-time, sporadically, at least a couple months, putting the thing together. It really was nice because, you know, the phases were broken up really nicely. So you can write little modules for one, downloading an app from Apple, two, cracking the thing, doing all the rest, and then it was just sort of combining all those phases together. So I would say maybe 3 to 4 months total amount of time. I was thinking about open sourcing the thing because maybe other people could use it or at least have fun with it. Otherwise, it'll just rot because I don't update it. But maybe. I feel like there's this thing about open source where I feel sort of scared because if I take all this code and I open source it, everyone's going to see how crappy of a developer I am. And so, like, I've kind of like held off on that. But you know, I feel like, you know, some people would probably find it useful.
So, because with the advent of all these, you know, more and more hardcore obfuscation protection mechanisms, would that present kind of a challenge to, like, debugging or hacking through this manner?
Yeah, so just to repeat, since they didn't hear, his question was, hey, when you look at mobile apps, obfuscation and sort of tampering type of technologies that are going to mobile apps, does it prevent this? Absolutely. And in fact, great question. In Blue Box, that was a sort of a solution we created to help do this. But so there's two things. What you find most often is that people will use technology to obfuscate code. So obfuscation of code will not stop this. Obfuscation of code only stops people from static analyzing the code. So if I want to run it in IDA or if I want to go through it, obfuscation of code absolutely makes that very difficult to do. What's great is you can take an obfuscated binary and in runtime it doesn't matter, right? I inject my code, I run with the app, I don't care about obfuscation, right? I'm running live inside of the app, obfuscation makes no difference to me. But if you start adding things like what we did, we wrote libraries that would hook mobile API calls and look for things like tampering, loading of libraries that aren't supposed to be there, hashing and making sure that what's loaded is supposed to be loaded. Those absolutely kill this type of attack.
I have a question. I haven't do iOS for a while, but what I remember is like each individual app has its own sandbox. So how did your app manage to get into reading other sandboxes?
Yeah, great question. Because I don't have to break the sandbox. I am part of the app. So what's great is what I'm doing is when I take the Facebook app, for example, I take Facebook, I decrypt the binary, I create essentially a second binary, the Facebook app, I add my code inside of it. And then what happens is when it runs on the device, it's signed by me as a developer, and so it thinks it's my own custom app. And so when Facebook loads, it loads my code in that sandbox. So I'm not breaking sandbox here, I'm just running inside of it. It's essentially the same thing that says, well, hey, trying to protect someone from breaking into your house, you can go and lock the windows and lock the doors. But if you invite the person in, and the person's sitting at dinner with you and eating, that's what I'm doing, right? It's the equivalent. I don't need to break the
So
sandbox.
how it
I'm
works
in
is
there.
like use your app to go to the installation and download the binary into your app and then run it.
What's that?
I mean, is it like your app, use your app to go to the app store to download the version and into your binary
Yes.
and then run it?
Yeah, think about my binary as a payload in Metasploit, right? It's the actual exploit payload. I take the binary, I throw it in there, it all becomes one package, it runs. And it's great because then you can run this on non-jailbroken iPhones, right? And so it doesn't matter what version, up to date, fully compliant, you can run it and you can still reverse it.
Another question?
If I were to look at the entire, queue chain, the one critical point is actually the ability to decrypt the app so that you could run it. So would that be, the area where controls would focus the efforts on to prevent the decryption of apps?
Yes, so if you cannot jailbreak, if you cannot run a jailbroken device, this falls apart. It's a very good point. So I think his point is that if you cannot decrypt it, then you can't inject it, you can't make it part of your app. Absolutely, you have to rely on a jailbroken device in order to make this work. Any other questions? Oh,
Hey Caleb, how you doing?
hey, Ryan, how are you?
Yeah, we wanted to ask about for people or individuals out there that are new to, that want to get into web application testing, what are some things that you recommend they take a look at?
Okay, so so that's a great question. I would say that if you want to get into web application testing or mobile application testing or anything involving web security or app security, the number one thing you need to do is be a developer. Just learn the technologies. Learn to code an app, learn to write a web page, learn how to build something. Just learn to be a developer, so follow the exact same steps any developer would take in order to build something. You have to understand the technologies. See, the key thing about it is, I think, going back to previous talkers, that when you look at something, that technology, it's not like, don't jump into it just trying to break it, right? You need to, a hacker looks at a technology and then figures out what are the interesting ways that there are loopholes in it, and what can you think about it. But in order to do that, you have to really know the base technology. So understand the fundamentals, understand the foundations first of that technology, then you can look at it in a different perspective on, hey, now I understand all this, what are ways of subverting things? What are the mistakes that developers make that are common, right? Because one of the things I found is, hey, I need to keep secret tokens in order to access these backend service APIs. Where do you store it, right? You got to get it from somewhere. Do I store it encrypted? Well, yeah, you can, but man, that's a pain in the butt, right? And then you start learning, oh, if it's a pain for me, then it's a pain for all the other developers, and they're making that same mistake. They're probably storing these same tokens in an unsecured way. All right?
Quick question. So you have go through a number of applications. Which of the application is most scary? The result is most scary to you. Like, is it the seminar, the conference app?
No, not at all. I would say that there is a very large brokerage application that I was able to get back-end access to through their mobile APIs because I found something very similar. I found a developer screen. I found where they upload log files to their back-end through the app itself, and then through that you could get remote command execution on the back-end. That was probably one of the scarier ones. Because, I mean, look, at the end of the day, I mean, mobile apps are nothing more than a front end to what you're doing on the back end. If you don't secure the back end, all the mobile app does is give you extra attack surface and areas that developers just aren't thinking about, right, from a security perspective.
Just now I saw a lot of icons, and one of them is like your famous WeChat one. So, like, this is something that I find out that we should know or something.
I don't think I could. It's just an icon.
I'll ask you during the break.
Okay, all right. So I think this is probably a good spot to call it. I'll be here, so you guys can always ask me questions. Thank you very much.
Stay on page.
Hang on a second, we have something, right, from Alan, one of the DC members. Oh,